The topic of my talk is stabilisation of verdigris, application of research in conservation practice. Verdigris is a collective term for copper acetate with different compositions and is one of several green pigments. Verdigris is produced by reactions of metallic copper with acetic acid in the presence of oxygen. As an easily available pigment, verdigris has been frequently used on paper. The pigment was applied in thick layers or in a diluted form to color drawings and prints. Depending on the support and the manner of application, the green color can penetrate to the verso of the paper. Colored areas can turn brown. On recto and verso, copper ions cause degradation of the paper support. As many of you know, the paper becomes brittle and tears easily. In images from the atlas Harmonia Macrocosmica by Andreas Cellarius, you see brown discoloration on recto and verso of areas which were initially green. The aim of a research project funded by the Austrian Formous program was to find methods to stabilize verdigris on paper, to chemically stabilize copper ions which cause deterioration of cellulose, and to mechanically stabilize paper damaged by verdigris. The project was a cooperation between the Austrian National Library and the University of Natural Resources and Life Science, Vienna. During the last 3 years, we have tried to apply the results in the conservation of books with colored prints and drawings. I would like to give you a brief overview of the results of our project, and then I will present the conservation of one atlas and 2 volumes of books with images from cities. And I've chosen the most controversial case studies. In the research project, samples were prepared by applying copper acetate in gamma arabic to handmade gelatin-sized paper in thick and thin layers of paint. The pre-aged samples were treated with different solutions of deacidification, antioxidant, and complexing agents. The treated samples were submitted to accelerated aging at 80% relative humidity and 65 degrees Celsius. An additional set of samples was light aged. In the slide on the screen, you see samples treated with a 0.5% solution of benzotriazole by airbrush on the suction table after treatment, then after light aging in the middle, and after thermal aging. After post-aging, the cellulose was analyzed by gel permeation chromatography. For mechanical stabilization, Japanese tissue papers were coated with different adhesives and adhesives mixtures. The pre-coated papers were activated with water or ethanol and applied to the samples recto and verso. After aging, the pre-coated papers were visually assessed and compared. A 3% solution of benzotriazole in ethanol, applied by brush from the verso, stabilized cellulose after thermal and after light aging. BTA is a strong complexing agent for copper that has been used in industry and in metal conservation. BTA clearly stabilized cellulose in the presence of copper compared with the other methods evaluated by cellulose analysis. But light aging caused discoloration of BTA-treated rag paper, as you can see on the slide, which can be, these are samples that were treated with a 3% BTA solution applied by brush from the verso. The discoloration depends on the concentration of BTA. A 0.5% solution causes less yellowing than a 5% solution. Pre-coated Japanese tissue papers proved to stabilize rag paper mechanically without inducing further damage after light and after thermal aging. Homogeneous and matte films can be achieved by brushing dilute adhesives on a silicone mat. Activation of pre-coated papers with the sponge plotter system developed by Jacobi et al. Reduces the risk of migration of copper ions. In our study, Japanese tissue papers coated with a mixture of wheat starch paste and methyl cellulose, gelatin and glucyl G in ethanol proved to provide sufficient support for rag paper. A coating with glucyl in ethanol, activated with ethanol, offers a non-aqueous alternative. When gelatin and glucyl G are mixed, the gloss of gelatin can be reduced. After thermal and after light aging, the adhesive coatings showed only minor color change. For further information on the research project, I refer you to the publications in Heritage Science, Restaurator and Carbohydrate Polymers. And now I would like to present you the two case studies that I've chosen. Harmonia Macrocosmica by Andreas Cellarius is an atlas with images of planetary systems and celestial maps. The book conserved was printed in 1708 in Amsterdam. The rag paper is in good condition. The green color was applied diluted or in thick layers. Most green colored areas have turned brown on recto and verso. In the part of the map which has been attached to the guard, the green color is sometimes protected by the hide glue of the guard and has preserved its original color. Especially areas that are exposed to more mechanical stress when the papers are turned have smaller or larger tears due to the embrittlement and the loss of flexibility of the cellulose. Civitatis Orbis Terrarum by Georg Braun and Franz Hoggenberg is a 5-volume book assembling over 450 descriptions and images from cities of the world in Renaissance time. The Latin edition, in a collection of rare books, dates from 1582 onwards. In volume 1 to 4, the prints depicting cities are colored. The paper quality differs from volume to volume. The paper is generally yellowed and shows signs of negligent production, such as thin areas, faults, and metal impurities. Many, but not all, green areas have changed to brown. In most cases, the green coloration has migrated to the verso, in case of discoloration in its brown form. There are many pages where brown discoloration has also migrated to adjacent pages. At some point, the volumes were exposed to high humidity, which has resulted in water stains and mold spots. The degradation caused by copper-containing pigments is especially pronounced in volumes 2 and 3. White crystals found in volume 3 were identified as allium by FDR analysis. We assume that the degradation of the paper caused by copper ions was facilitated by poor quality paper, the content of alum, and at some point the influence of high humidity. Copper ions in the atlas Harmonia Macrocosmica and Civitatis Orbis Terrarum were detected with non-bleeding copper ion indicator papers. These indicator papers were prepared by Ute Henniges and Christina Trucekajte based on the publication of Peter Hulte. Hofmann paper is impregnated with bathocuprine in ethanol. Strips of the indicator paper are humidified with a drop of deionized water. Excess water is blotted off, and the paper strips are put on areas with green coloration under light pressure. In the presence of copper ions, the indicator paper turns orange to brown, depending on the quantity of ions. The indicator papers are used to detect copper ions in green coloration and to monitor treatments. We had intense discussions about chemical stabilization in the conservation of the two objects. The pros and cons of the application of BTA were considered. Finally, we decided to locally apply a 3% BTA solution in ethanol to verdigris that showed brown discoloration on the verso in both case studies. We wanted to stabilize strongly degraded areas and prevent further deterioration of pages in still better condition. Many green areas already showed a more or less pronounced color change. If the PTA solution will cause yellowing during aging, the color change will probably not be visible, especially on brown verdigris. Application of PTA by brush was limited to green coloration. The paper in the books of Civitatis Orbis Terrarum is yellowed by natural aging. We assume that possible yellowing of PTA will not show on these pages. Yellowing of PTA on our samples was observed after light aging. It was decided with the collections that access to the books was to be limited following conservation treatment. Both objects will not be exhibited. Pages treated with PTA will be exposed to very limited amounts of light. A 3% solution of PTA in ethanol was applied with synthetic brushes to the verso of areas with discolored verdigris. The use of ethanol prevented deformation of the paper and mechanical stress to the brittle paper. Initial tests showed that a one-time application seems sufficient. The solution was applied from the verso with the aim of complexing copper ions and thus protecting the paper support. As PTA is harmful to health, the treatment was performed under a fume hood with protective garments. In these slides, you see the image of Danzig in volume 2, recto and verso. The detail of the city is shown on the left before and on the right after treatment with PTA. Visually, we could not observe color changes in the different green hues after one-time application of PTA from the verso. The effect of complexing was monitored with copper ion indicator papers. In areas in which verdigris had discolored to brown, the indicator papers showed an orange reaction. Overall, or orange spots. The application of PTA was judged sufficient when the copper indicator paper showed no or light orange reaction on the verso of verdigris. In the slide you see the indicator paper on the detail of Danzig before and after treatment. The indicator papers were used to monitor conditions 2 years after the treatment. The reaction was similar to the test in 2013. According to the indicator papers, the complexing reaction seems to be stable. For mechanical stabilization of tears and very brittle areas, the following Japanese tissue papers were used. We chose RQ1 by Paper Now to support large areas of verdigris on the verso in the atlas. In Civitatis Orbis Terrarum, areas of verdigris that needed reinforcement had in many cases printed text on a verso. We decided to use RK00. On the recto of verdigris, RK00 or KR4C were applied in cases where a tear had to be secured from both sides. KR4C, a cream-colored 4-gram paper, was applied on very dark areas because it is less jarring than a white paper. For the stabilization of large areas, like on maps in Harmonia Macrocosmica, the pre-coated Japanese papers were applied in small pieces following the form of a large colored area. The papers were coated with a mixture of 3 parts gelatin, Gelita photographic gelatin, type B, 2.5%, and 1 part Clucel G, 2.5% in water. The adhesive mixture was applied on a silicone mat to reduce gloss. The pre-coated papers were activated by the sandwich system, which consists of a kitchen cloth, humidified with water, and a blotting paper on top, as you can see on the slide. The cut Japanese papers were smoothed out, adhesive layer down, on the humid blotting paper with a soft synthetic brush. With a pair of tweezers, the activated Japanese paper strip was transferred to the verso of the verdigris. The paper strip is laid out on the verso and put in contact with a Surobaka brush. The reinforcement was dried under blotting paper and the weight of lead snakes. The pre-coated Japanese papers provided sufficient support to the degraded rag paper. 2 years after the treatment, the reinforcements are stable. In the case of 2 objects with strong degradation of verdigris, we decided to apply the copper complexing agent BTA locally by brush from the verso. In the conservation of manuscripts, and you see one example on the screen, and one incunabula, we limited the treatments to mechanical stabilization of damaged paper with pre-coated papers. For the 2 objects presented here, the risk of further damage by copper ions appeared to be higher than the risk of color changes on brown verdigris and the risk of yellowing on yellowed paper. Further research on the action, the application, especially the concentration and the long-term effect of BTA on paper is definitely necessary. The treatment of Harmonia macrocosmica and Civitatis orbis terrarum showed that the pre-coated tissue papers offer good support even for large areas and do not cause mechanical deformation of very brittle paper. Very thin and cream-colored papers appear discrete on colors or text. Activation of the adhesive layer with the sponge plotter system reduced the risk of migration of copper ions and was practical in application. Pre-coated Japanese tissue papers have found wide application in our department, not only for verdigris, but also for the stabilization of iron galling. Thank you for your attention.